Okay, in this video, we're going to learn about arithmetic sequence. Okay, now let's look at what is meant by sequence. So, sequence of numbers is a list of numbers that are arranged in a definite order. So, example of sequence is 1, 3, 5, 7, and so forth. Okay, how about series here? So, series is the sum of the terms in the sequence. Okay, so series is the sum. So example here, 1 plus 3 plus 5 plus 7 and so forth. So when you total up the numbers, then we call it as a series. Sequence also frequently referred to as progression. So for example here, arithmetic sequence, we also can call it as arithmetic progression. Okay, in an arithmetic sequence, each term is obtained by adding a constant number to the term preceding it. So this constant number, we call it as common difference. So the common difference between any two consecutive terms is always the same. Okay, now look at what is meant by common difference here. Okay, look at this example. Okay, first sequence that we have here is 4, 8, 12, 16 and so forth. Okay, the first number is 4, second number or second term is 8. So if you look at here, from first number or first term, how we get second number? And from second number, how we get third number? Okay, if you look at here, 4 plus 4, we get 8. And then 8 plus 4, we get 12. Okay, so that is meant by common difference between any two consecutive terms is always the same. So value D here, how to find value D? Common difference. Okay, common difference is obtained by subtracting any term from the term which immediately follows it. Okay, just now we say that for arithmetic sequence, each term is obtained by adding a constant number. So from first number or first term, from left to right, we add. So in order to find common difference, reverse, okay, from right to left. So that's why we subtract. Okay, how we get 4? 8 minus 4, we get 4. 12 minus 8, we get 4. 16 minus 12, also we get 4. Okay, so that is meant by common difference between any two consecutive terms is always the same. Okay, so value of D must be the same throughout the sequence. Okay, thus if you want to find D, for example here, if you use T1 and then it must be minus T1. If we use T4, then minus T3. Okay, so if we use T10, and then D equal to T10 minus T9. If we use T6, and then D equal to T6 minus T5. So in general, common difference D is given by, so D equal to Tn minus Tn minus 1. So note here that n referring to which term. Okay, so example, in the first example here, so 16 is the fourth term, okay, T4. So T4, so n equal to 4. T4, so n equal to 4. So n minus 1, 4 minus 1 is 3, right? So D equal to T4 minus T3, okay? So it must be any term from the term which immediately follows it. So you cannot do like this. For example, D equal to T4 minus T2, for example. Okay, that one is wrong. Or you put T4 minus T1. Okay, that one also cannot. Okay, now let's look at the general term for arithmetic sequence. Okay, note that the first term, which is T1, the first number, also denoted by A. So now A referring to the first term. Okay, look at general term for arithmetic sequence. So Tn equals to A plus n minus 1 multiplied by D, where D just now is the common difference. N is the number of terms. Number of terms means that in that sequence, it has how many numbers, okay? And A referring to the first term or the first number. Okay, now let's look at example. Okay, so here I give you the 10 terms. So in general, how we write T10 for arithmetic sequence? So how I get A plus 9D? So if you look at the general term here, T10. So A is the first term. So in general, so assuming that we don't have any sequence, so first term is A plus n minus 1d. So T10. So now n equal to 10. So 10 minus 1 multiplied by d. Okay, so here we get T10 equal to A plus 9d. Okay, A plus 9d. So 10 minus 1, 9. Okay, so if you look at here, if you want to find the 53 term, so will be A plus 52d. Okay, so n minus 1. If you want to find the 100th term, so will be A plus 99d. So n minus 1 here. 100 minus 1, we get 99. Or another example, okay, let's say you want to find the 20th term, so T20. So how to find general term for T20? 20 minus 1, 19. So the T20 equal to A plus 19D. Okay, so that's how we construct or we find general term for arithmetic sequence. Okay, recall back for common difference here. Okay, let's say this example, second example, how we get negative 4. Okay, so if you want to prove how to get negative 4, so it will be T2 minus T1. So T2 negative 9 minus negative 5. So you get negative 4. Or T4 minus T3. It must be T4 minus T3. You cannot do T4 minus T2. Negative 17 minus negative 13. Also, we get negative 4. Or T3 minus T2. So, negative 13 minus negative 9. Okay, also negative 4. Okay, similarly here, how to get common difference? D equal to negative 1 over 4. So 0 minus 1 over 4, you will get negative 1 over 4. Or T2 minus T1, 3 over 2 minus 7 over 4, also you will get negative 1 over 4. Okay, now look at this example. Okay, what are the 12 and n terms of the arithmetic sequence? 12, 5, negative 2, and so forth. Okay, now we want to find the T12. Okay, so from the given sequence, okay, we know that the first term or T1 is 12. Okay, so you write A equal to 12. Okay, so when you have these three numbers, first three numbers, we can find the common difference. So how to find common difference? 5 minus 12, we get negative 7. Or you also can find it based on T3 and T2. Negative 2 minus 5, also we will get negative 7. Okay, now we want to find the general term for T12 of this sequence. Okay, so T12. So you write in general term, which is Tn equals to A plus n minus 1 d. So we want to find T12. So T12, so n equal to 12. A plus n minus 1 d. So substitute the value. So A first term, first value. So A equal to 12 plus n. So n is here. N equal to 12 minus 1 multiplied by d, common difference. So common difference equal to negative 7. Okay, so when you solve this one, okay, so 12 minus 1, 11. 11 multiplied by negative 7, you will get negative 77. So 12 minus negative 77 equal to negative 65. So what is meant by negative 65? So the 12th term, the 12th number in the sequence is equal to negative 65. Okay, then next question here, the nth term. Okay, the nth term is that for this sequence in general, what is the nth term? Okay, so we substitute a equal to 12. Okay, so since we do not know which number we want to find, so that's why we put n equal to n, and then d equal to negative 7. Okay, before that, if you look at your notes, there is some mistake here in the step. Okay. Look at this part. Okay, how to solve this one? You expand this part first. Okay, you make some correction here. So 12 plus, okay, n multiplied by negative 7, we get negative 7n. So negative 1 multiplied by negative 7, we get positive 7. So here we will get, okay, 12 plus 7 is 19. And then minus 7n. Okay, so in general, the n term for this sequence is given by 19 minus 7n. So what is meant by 19 minus 7n? Okay, look at this sequence. Okay, let's say here second term for t2 equal to 5. Okay, we want to use this formula, the general term or the n term for this sequence. Okay, so we know that Tn equal to 19 minus 7n. Okay, so 19 minus 7n. Okay, we want to prove that T2 here equal to 5. So T2 equal to, okay, use this formula or the general formula for this sequence just now. General term for this sequence. So 19 minus 7n. So if T2, so means the n equal to 2. So substitute n equal to 2. So here we get 19 minus 17. 19 minus 14. So 19 minus 14 is 5, right? So that's meant by general term. Okay, so T2 equal to 5. So here T2 also equal to 5. Okay, let's say for this sequence, we want to know, okay, what is the 100 number in this sequence, okay? So we use this general term, okay? So we want to know the 100 number for this sequence. So T100 equal to 19 minus, so now n equal to 100, okay? So 19 minus 7 times 100. 7 times 100 is 700. So 19 minus 700 is negative 681. Okay, so the 100 number in this sequence is negative 681. So that is meant by the n term, okay, n term for this sequence. Okay, now let's look at this exercise. Okay, look at number 1. Okay, what is the 35th term of the arithmetic sequence 5, 9, 13, and so forth? Okay, so first of all, you list the information given. Okay, so from this sequence, we know that the first term A is equal to 5 or T1. Okay, so A equal to 5. And then we can find common difference. So how to find common difference? T2 minus T1. Okay, so 9 minus 5 equal to 4. Or you also can find common difference using T3 and T2. Okay, so 13 minus 9 also we get 4. Okay, now we want to find the 35th term, means that T35. Okay, So what is the 35th number in this sequence? Okay, since it is an arithmetic sequence, so use the general term for arithmetic sequence. Okay, Tn equals to A plus N minus 1D. Okay, substitute the value. So we want to find T35. So T35. So N equal to 35. So A first term equal to 5. So N referring to 35 here. So substitute N equal to 35. And D, which is common difference, equal to 4. So here you solve value in bracket. So 5 plus 35 minus 4, 35 minus 1 is 34. 34 times by 4 is equal to 34 times 4 plus 5. So 141. So the 35th number in the sequence is 141. So that's how we find the nth term in an arithmetic sequence. Okay, now look at number 2 here. The 7th term of an arithmetic progression is 27. So 7th term, so means that T7. So T7 equal to 27. Okay, we list the information given. Okay, and the 12th term is 47. 12th term means that T12. Okay, T12 equal to 47. Okay, so the 7th term 27 and the 12th term is 47. Determine the arithmetic progression. Determine the arithmetic progression means that what is T1, T2, T3 and so forth. Okay, so for this type of question, at least we give first 3 numbers, okay, or first 3 terms. Okay, how to solve this question? Okay, first we write T7 and T12 in its general term. Okay. So general term for arithmetic sequence is Tn equal to A plus N minus 1 D. Okay, now we write T7 in its general term. So T7 equal to A plus, okay, T7, now N equal to 7. So 7 minus 1 multiplied by D. Okay, so now we do not know what is first term and what is common difference. So you just substitute A equal to A and D equal to D. Okay, we know that T7 equal to 27. So T7 equal to 27 equal to A plus 7 minus 1, 6. 6 times D equal to 6D. Okay. Okay, now we get one equation here. So you let this one be the first equation. Okay, next, write T12 in its general term as well. Okay, so we know that T12 equal to so N equal to 12. So substitute here N equal to 12. So T12 equal to 47. A equals to A plus 12 minus 1, 11 times D, 11D. Okay, now you let this one as second equation. Okay, in order to get T1, T2, T3 and so forth, we need A, the first term, and value D, common difference. Okay, so once we have value A and value D, then we can find T2, T3 and so forth. Okay, for this example, we need to apply simultaneous equation, okay, because here we have two unknowns value A and D, so what we can do, we can apply simultaneous equation, okay. So here, in simultaneous equation, you can use either elimination method or substitution method. So if you look at these two equations, okay, look at A. Okay, the multiplier for A here for both equation is 1. A means 1A. Okay, if 6D here, the multiplier is 6. Okay, here the multiplier for D is 11. Okay, we need to eliminate one unknown value first in order to get the other value. So from first equation here, we look at A, the multiplier is 1. Second equation, the multiplier also equal to 1. So the easiest way is, instead of we eliminate D, we eliminate A first. Okay, so how to eliminate A? So what we can do, equation 1 minus equation 2. Okay. So what is equation 1? A plus 6D equal to 27 minus second equation, which is A plus 11D equal to 47. So equation 1 minus equation 2. Okay, here if you look at A minus A equal to 0. 1A minus 1A equal to 0. Okay. Okay, 6D minus 11D equal to negative 5D. 27 minus 47 is negative 20. So how to find D? So D equal to negative 20 divided by negative 5. Okay, negative 5D means negative 5 multiplied by D. So D equal to negative 20 divided by negative 5. So D equal to negative divided by negative positive. So D equal to negative negative positive. So 20 divided by 5 is 4. Okay. So now we get value common difference equal to 4. So how to get A? Substitute value D into any equation in order to get T1 or value A. Okay, substitute D equal to 4 into equation 1. Let's say I put into equation 1. So equation 1 just now is A plus 6D equal to 27. Okay, substitute D equal to 4. So A plus 6 times 4 equal to 27. A plus 6 times 4, 24 equal to 27. So make A as the subject. So A equal to 27 minus 24. So A equal to 3. Okay, now the question asks you to determine the progression. Means that what is T1, T2, T3 and so forth. So the sequence or the progression is, so T1 is A. So value A just now is 3, second term. So from first term, how to get second term? We need to add common difference. Okay, so T2, first term plus common difference. So 3 plus 4 equal to 7. So if you have T2, how to get T3? Plus again common difference. So 7 plus 4 equal to 11. Okay, how to get fourth number or fourth term? Again, plus the common difference. So 11 plus 4 is 15 and so forth. Okay, so at least we give the first 3 or first 4 numbers. Okay, now let's look at number 3 here. How many terms are there in the arithmetic progression 1 to 3, 1 to 9, 1 to 5 until the last term or last number is 255? So again, question asks us how many terms? How many terms? So meaning to say that we want to find value n. Okay. So in this sequence, we have how many numbers? Okay, first extract the information given. So we know that 1, 2, 3 is the first term. Okay, so A equal to 1, 2, 3. and then common difference D equal to 129 minus 123. So 129 minus 123 equal to 6. And then we know that last number is 255, but we do not know for which term. Okay, so in general we can put it as Tn. Okay, Tn equal to 255. Okay, so for example here, T1 or A is 123, T2 is 129, T3 is 135, but 255 is unknown. Okay, so in general we put it as Tn. Okay, now we use formula general term for arithmetic. So Tn equals to A plus n minus 1 D. Okay, substitute the value. So here we have Tn equal to 255. A is 123 first term. Okay, now we want to find value n. And then multiply by common difference. So here common difference is 6. Okay, expand this part. N times 6, 6n minus 1 times 6 equal to 6. Okay, now make n as the subject. 6n equal to 255 minus 123 plus 6. So 6n equal to 255 minus 123 plus 6. 138. So n equal to 138 divided by 6. So equal to 23. So 255 is actually T23. So all together in this sequence we have 23 numbers. Okay, now look at number 4. What is the sum of the first and odd numbers? Okay, now sum. Okay, so before this we learned about the term. Okay, now about sum. Okay, the series. Okay, if you look at formula sum for arithmetic sequence, okay, so this is general term. Okay, now sum. So sum of arithmetic sequence is given by Sn as referring to sum and referring to number of terms. So Sn equal to n over 2 multiplied by 2a plus n minus 1 multiplied by d. Okay, now look at how to find the sum of an arithmetic sequence. Okay, look at this question. Okay, it asks us about the first and odd numbers. Okay, let's say we list the first 3 odd numbers. Okay, so 1, 3, 5. Okay, let's say I give first 4 odd numbers. 7 and so forth. Okay. So what is the sum? Meaning to say that, okay, let's say if I just have 1, 3, and 5. Okay, so the sum will be 1 plus 3 plus 5. So 1 plus 3 plus 5 equal to 9. Okay, now we want to find the sum of the first and odd numbers. Okay, let's say we use this one, 1, 3, 5, 7, and so forth. Okay, we know that A equal to 1. The first term A equal to 1. And then common difference D equal to 2. Okay, so how we get to 3 minus 1. Or you also can put D equal to 7 minus 5. Also we get 2. Okay, what is the sum? So if question asks you sum, so use formula sum. Okay, Sn. Don't use formula Tn. Okay, so Sn equal to n over 2 multiplied by 2a plus n minus 1 times d. Okay, substitute the value that we have. So n is unknown. 2a first term is 1. Again, n is unknown, and then the common difference here equal to 2. Okay, expand this formula, we will get, so Sn equal to n over 2 multiplied by 2 times 1, 2 plus n times 2 to n, negative 1 times 2, negative 2. So here, Sn equal to n over 2. Okay, simplify value in bracket. So 2 minus 2 is 0. So here multiply by 2n. Okay. So 2 over 2 equal to 1. So at last, Sn, we will get n squared. Okay. Okay, so what is meant by n squared? So in general, the sum of the first and odd numbers is given by n squared. Okay, let's say we have here just now. So assume that we have 1, 3, and 5 only. So the sum is 9, right? So meaning to say that in this case, we have 3 numbers. So n equal to 3. Okay, we know that just now, the general sum of the first and odd numbers equal to n squared. So here, you just substitute as n equal to 3 squared. So 3 squared equal to 9. Okay, so that is meant by sum of the first and odd numbers. If I give you another example, let's say we have 1, 3, 5, 7, and last number is 9. Okay, what is the sum? So the sum will be 1 plus 3 plus 5 plus 7 plus 9, right? So 1 plus 3 plus 5 plus 7 plus 9. So equal to 25. So if you use this formula, so we have 5 numbers, 1, 2, 3, 4, 5. So 5 square equal to 25. Okay, if we have, let's say, less number of term less than 10, it is easy for us to compute the sum, okay? Okay, now let's look at number 5. Consider the arithmetic progression 73, 67, 61, 55, and so forth. Okay, if find the sum of the first 12 terms. Sum. Okay, so we want to find S12. So S12 equal to 1. Okay, so if you want to find sum, make sure we use formula sum. Okay, again, this is the information given. So we know that A first term equal to 73 and common difference D equal to 67 minus 73. Okay, T2 minus T1 or 61 minus 67. So 67 minus 67 minus 73 is negative 6. Okay, now we want to find S12. So Sn. So n here equal to 12. Okay, sum of the first 12 numbers in this sequence. Okay, use formula sum. So Sn equal to n over 2 multiplied by 2a plus n minus 1 d. Okay, substitute the respective value. So here n equal to 12. A first term equal to 73. And again equal to 12 minus 1 multiplied by common difference d equal to negative 6. Okay, simplify this one as 12 equal to 12 over 2 is 6. Multiply by 2 times 73 equal to 146 plus 12 minus 1, 11. 11 times negative 66 is negative 66. So I put like this, 12 minus 1, 11, multiply by negative 6. So I show one by one first. So 6 in bracket 146. So positive 11 multiplied by negative 6 is negative 66. So as 12, sum of the first 12 numbers is 146 minus 66 is 80. 80 multiplied by 6 equal to 680. So in this sequence, if we total up the first 12 terms, we will get 640. Okay, question B. What is the 12th term of the progression? Okay, 12 terms. So it means that we want to find T12. So T12 equal to what? Okay, so we know that A just now equal to, so A just now is 73 and D equal to negative 6. Okay, T12, so we use formula Tn, okay, because we want to find the term. So T12 equal to, so use formula Tn. So now we want to find T12, so n equal to 12, E equal to 73. So again n equal to 12 minus 1 and then the common difference is negative 6. So T12 equal to 73 plus 12 minus 1, 11 multiplied by negative 6. So 73 minus 66 is 7. So T12 equal to 7. Okay, so in this sequence, okay, the 12th number or the 12th term is equal to 7. So first term, second, third, fourth term. So the 12th term here will be equal to 7. Okay, now number 6. How many terms? So how many terms? So meaning to say that we want to find value n of the arithmetic sequence 3, 7, 11, 15 and so forth that must be added to obtain a total of 300. Total of 300. So now in arithmetic sequence, we already learned about the term and the sum. So in this question, we need to use formula sum. Okay, why we need to use formula sum? Because it says that must be added to obtain a total of 300. So we need to use formula Sn. Okay, now extract the information given. Okay, now we want to find Sn, how many numbers we need to add, okay, in order to get a total of 300. Okay, so Sn equal to 300. Okay, then we have first term equal to 3 and common difference equal to 4. 7 minus 3 equal to 4. Or you also can use T4 minus T3. 15 minus 11 also you will get 4. Okay, how many numbers that we need to add in order to get 300? Okay, since we have information about total, so we use formula Sn. Okay, now substitute the values that we had. So we know that Sn equal to 300. So n is unknown. Okay, n is unknown here. A first term equal to 3. Again, n is unknown, and common difference here, d equal to 4. Okay, simplify this one. So 300 equal to n over 2 times 2 times 3 equal to 6 plus n times 4 for n minus 1 times 4, 4. Okay, then simplify this one. So 300 equal to n over 2. So value in bracket 6 minus 4 equal to 2 plus 4n. So 300 equal to, so 2 divided by 2, 1. So n times 1, n plus 4 over 2, 2. N times n, n squared. So here n squared. Okay, now in this step, if you look at here, we have quadratic equation, okay, n squared. So if you still remember how to find value for n, okay, you can arrange this one into general form of quadratic equation, which is, for example, ax squared plus bx plus c. Okay, so you put it in quadratic form. So here we can arrange the equation become like this: 2n squared plus n minus 300. Okay, you let it equal to 0. Okay, so positive 300 you bring to this side become minus. Okay, so ax squared plus bx plus c. So now a equal to 2, b equal to 1. Okay, n means 1n. Okay, so b equal to 1 and c equal to negative 300. So how to find value n? Simply you can use function in your calculator. Okay, example here. Okay, you go to mod, then you look for eqn, which is equation. Okay, you press number 1. Okay, look for degree. Here you have right arrow here, press right arrow. Okay, look for degree. So highest degree here is power of 2. So you press 2. Okay, a is multiplier for n square, which is 2. You press 2, then press equal. Okay, b is 1n, so means that b equal to 1. Then press equal. And then value c is negative 300. So negative 300. Then press equal. Okay, first value of n you get 12. Okay, and then second value of n you get negative 12.5. So in this case, the logic value is x equal to 12. Okay, you need to add 12 numbers in order to get total of 300. Okay, why this one you cannot use? This answer you cannot use because it is negative. Okay, so the question asks us how many terms. So we cannot say that negative 12.5 terms. Okay, so the logic answer is x equal to or n equal to 12. Okay, what you can do, you can write your answer like this. So by using calculator, n1, n equal to 12. Okay, so we add 12 numbers from this sequence. Okay, then the total will be equal to 300. Okay, now question number 7. The sum of the first 8 terms of an arithmetic progression is 164. So again, sum. Okay, so we use formula sum. So given here, sum of first 8 terms. So SA equal to 164. and the sum of the first 6 term is 333. So it means that S6 equal to 333. Okay, determine the progression. Again, similar to like previous question, determine the progression means that what is T1, what is T2, what is T3, and so forth. Okay. Okay, so use formula sum for arithmetic sequence. Write S8 using sum formula. So here if S8 n equal to 8. So n equal to 8. So unknown value of A. So here n equal to 8 and D also unknown. So S8 equal to 8 over 2 is 4 times 2A. So 8 minus 1, 7 times D will be plus 7D. Okay, now we get first equation. Okay, before that we know that S8 equal to 164. So here we can substitute S8 equal to 164. Okay, so this one we let it be the first equation. Okay, now the same way write S6 using the sum formula. So now n equal to 6. So S6 equal to 333. Okay, simplify this one. 6 over 2 equal to 3 times 2a plus 6 minus 1, 5. 5d here. Okay, then we let this one be the second equation. So again, we use simultaneous equation in order to determine the progression or the sequence, since we have two unknowns value here. So from here, we can expand this one. 164 equal to 4 times 2, 8a plus 7 times 4, 28d. Okay, so this one we let it be the first equation. And then this one too, expand this part. So 3 times 2, 6a plus 5 times 3, 15d. So this one second equation. Okay, now look at how to eliminate A or D. So let's say I want to eliminate A first. Okay, so how to eliminate A? So this one the multiplier is 8. So this one the multiplier is 6. So how to eliminate A? Equation 1 multiply by 6 and equation 2 multiply by 8. So that A will get the same multiplier. So equation 1 multiply by 6. Okay. So 164 multiplied by 6 is 164 multiplied by 6 equal to, so the whole thing on right hand side here multiply by 6. 6 multiplied by 8a plus 28d. So 164 multiplied by 6 equal to 984. So 6 times 8 is 48a plus 28 times 6 equal to 165d here. Okay. Okay, now let's say I put this as third equation. Okay, now equation 2 multiply by 8. Okay, this one we want to get the common multiplier for A. So equation 2, 333 times 8 equal to, so the whole thing on right hand side multiply by 8 as well. 8 multiplied by 6a plus 15d. 333 multiplied by 8 equal to 2664. So 6 times 8 equal to 48. Here 15 times 8 equal to 120. Okay, let's say I put this one as fourth equation. Okay, now how to eliminate a, since we already have 48a and 48a here. So how to eliminate a? To eliminate a, equation 3, let's say I put equation 3 minus equation 4. Okay, so 48a minus 48a equal to 0. Equal to 0 means that a is eliminated. Okay, so equation 3 is minus equation 4. So here 984 minus 2664 is negative 1680. So 48a minus 48a equal to 0. So means that a is eliminated. So 168d minus 120d is 48d. So now we can find value d. D equal to negative 1680 divided by 48. So d equal to negative 35. Okay, once we get d, we can find value a. So just substitute value d equal to negative 35 into any equation here. Okay, now how to find value a? Substitute d equal to negative 35 into, let's say I put substitute into equation 1. Okay, equation 1 is 164 equal to 8a plus 28d. So d equal to negative 35. So 164 equal to 8a. So 28 multiplied by negative 35 equal to negative 980. So a equal to, so 8a equal to 164 plus 980. So a equal to 164 plus 980 equal to 1144. So a equal to 1144 divided by 8, which is equal to 143. So first term is 143. So question just now ask us to determine the arithmetic progression. What is T1, T2, T3 and so forth. So once we know value A, first term, and common difference D, then we can determine the sequence. So the sequence or the progression is, so T1 is A, so 1, 4, 3. So how to get T2, second term, we add common difference. So 1, 4, 3 plus negative 35 equal to 108. So how to get T3? 108 plus common difference, which is negative 35. So third term will be 73. Fourth term, plus common difference plus negative 35 equal to 38 and so forth. At least we give the first 4 numbers. So if you have questions something like this, it gives you the term or the sum, how to determine the progression or how to find the common difference and the first term, you can apply concept simultaneous equation.